Separation techniques. To analyze the composition of a sample that we suspect to be a mixture, it's important to separate its components and identify the individual substances present. Methods for separating mixtures all rely on differences in the physical properties of the components. A compound can be separated into its elements only by chemical change. However, because the components of a mixture retain their individual physical properties in the mixture, they can be separated by physical means. And we're going to look at 3 primary techniques for separation. The first is filtration. Filtration makes use of differences in solubility. The sample is shaken with a liquid and then poured through a fine mesh, the filter. In this example, the white area at the top of the beaker. The soluble material dissolves in the liquid and passes through the filter. The insoluble material, in this case the blue material, does not dissolve and is captured by the filter. The technique can be used to separate sugar from sand because sugar is soluble in water, but sand is not. The next technique is distillation, which makes use of differences in boiling points. Distillation separates the components of a mixture by vaporizing one or more of the components. In this case, the boiling point of the 3 fluids, that is the lowest, is the purple fluid, and it vaporizes first, leaving the yellow fluid and the raspberry colored fluid. Last but not least is chromatography. This technique relies on the different abilities of substances to adsorb or stick to surfaces. And the simplest version of this technique, the mixture is washed across a strip of filter paper, in this case the white paper. Substances that adsorb most weakly move farther than others, and if they are colored, give rise to separate patches of color on the paper. So these are the primary separation techniques. Once again, chromatography, distillation, and filtration. And that's it. Have a great day.